Lesson 2.2, solve two-step equations. What will we learn today? To identify the properties of equality and to solve two-step equations. Vocabulary. Properties, statements that are true for any number. Two-step equation, an equation that contains two operations.
Solve two-step equations. Mario bought 3 small bags of dog treats and 1 bag of cat food. The cat food cost $1, and the total cost was $7. But the receipt did not show the individual cost of the dog treats. The solution to this problem can be found by solving the two-step equation, 3x plus 1 equals 7, where x is the cost per bag of dog treats. A two-step equation contains two operations. 3 times the value of x, then 1 is added. To solve two-step equations, undo each operation in reverse order. We will use two methods to solve 3x plus 1 equals 7. In the first method, we will use a model to solve the equation. First, model 3x plus 1 equals 7. Next, remove 1 from each mat. Separate the remaining tiles into 3 equal groups. There are 2 1 tiles in each group, so x equals 2. You can also use symbols to solve 3x plus 1 equals 7. First, use the subtraction property of equality. Subtract 1 from each side. Next, use the division property of equality to solve for x. Divide each side by 3. Finally, simplify. So, using either method, the solution is 2. So, the cost of 1 bag of dog treats is $2.
Solve two-step equations. A two-step equation contains two operations. In the equation 2x plus 3 equals 7, x is multiplied by 2, right there, and then 3 is added. To solve two-step equations, undo each operation in reverse order. So in other words, the last thing we're going to do is isolate the variable. Remember, our goal is to isolate the variable. So the first thing we need to do is I need to get rid of the plus 3. And the way I get rid of the plus 3 is I do the opposite of adding, which is subtracting. So I'm going to subtract 3 from both sides. So the 2x remains the same. A positive 3 minus 3 becomes 0. That's going to equal 7 minus 3. 7 minus 3 is 4. My next step, isolate the variable just like we did in lesson 1. Here I'm going to divide by 2 because I have the coefficient of 2. 2 divided by 2 becomes 1 or cancels out. So I'm left with x is equal to 4 divided by 2. I can check the work. I can go, well, 2 times 2 plus 3. Again, this is my checking. Will that equal 7? 2 times 2, 4. 4 plus 3 equals 7. So this is correct. My answer will be x equals 2. Example 2, we have a fraction in this problem. We have solve 25 is equal to 1/4 n minus 3. Once again, our goal, isolate the variable. In this case, it's the n. Okay. First, I need to add 3. The opposite of subtracting is adding 3. So I'm adding 3 to both sides. That eliminates this over here, makes that 0. 25 plus 3 is 28 equals 1/4 times n. Just like we did in our lesson 2.1, we multiply by the reciprocal. The reciprocal of 1/4 is 4 over 1. 4 over 1 times 28. And on the right hand side, we're going to take the 4's cancel out, the 1's cancel out. I'm left with n is equal to, and 4 over 1 times 28 over 1, or just pretty much 28 times 4. And that's going to equal 112. So after my work, it tells me n is equal to 112. So let's check that. Will 25 equal 1/4 112 minus 3? So on my calculator, I'm doing this on the side, I'm going to take 1 divided by 4, that's 0.25, times 112, which is 28. So this right here gives me 28. 28 minus 3. 28 minus 3 is 25. So both sides of my equation balance. So my answer is n is equal to 112. Don't forget to check on these problems, boys and girls. Very important to check. Example 3, solve 6 minus 3x equals 21. Once again, isolating the variable. In this case, my variable is x. First, I need to get rid of everything around it. So I see this 6, and it's a positive 6. So it's minus 6. Now, ignore for now this part here. We're going to ignore that minus. That goes with the negative. That's a minus 3x. I'm just looking at the 6. The 6 is positive. So I'm doing the opposite, which is negative. So 6 minus 6, that eliminates that there. Subtract 6 on both sides. Let me erase that part there. Okay. So the negative comes along with the 3x. So it's negative 3x equals 21 minus 6, which is 15. Now, I have my variable has still not been isolated. So I'm going to divide both sides by negative 3. Negative 3 divided by negative 3 is 1, so that gets canceled. X is equal to 15 divided by negative 3, which would be negative 5. So let's check this. So if I take 6 minus 3 times negative 5, will that equal 21? Okay. So negative 3, here we have negative 3 times negative 5, which becomes a positive 15. Bring down my 6. 6 plus 15 is equal to 21. 21 equals 21. So my answer is x is equal to negative 5. Real world example, STEM. Chicago's lowest recorded temperature in degrees Fahrenheit is negative 27 degrees. Solve the equation negative 27 is equal to 1.8 C plus 32 to convert to degrees Celsius. So let me write down negative 27 equals 1.8 times C plus 32. And that's going to give us the degrees Celsius of negative 27 Fahrenheit. So same thing we did before. I'm going to get rid of the positive 32 by subtracting 32 to both sides. That becomes 0. Bring down my 1.8 times C equal to negative 37 minus 32. Well, two negatives, I'm going to add the numbers together. So it's actually negative 59. I need to isolate the C, so I'm going to take 1.8. So divide 1.8 on both sides. So I'm going to take negative 59. I'm doing this offline on a calculator. Divided by 1.8 will give me 32.77, and the 77 repeats. So I'll just go 778 equal to C. So let's check that out, see if that's our answer. So negative 27 does that equal 1.8 times 32.778, almost running out of room here, plus 32. Okay. So I'm going to take my 32.778 times 1.8, and actually that should be negative 32, sorry. So that's going to be negative 59 plus 32. That gives me a negative 27, and that's negative 27 here. So solve the equation negative 27 is equal to 1.8 times C plus 32 to convert to Celsius degrees. I'm going to say this is negative 32.778 degrees Celsius.